My name is Chelsea Shammy Calder, and I am your session host today. Up next, we'll be joined by Marcin of SAS and Adam of PKO, and they're going to be covering machine learning and network analytics for fraud detection at the largest bank in Central Europe. So please join me in welcoming them to the stage.
Great. Welcome, everyone. It's really a pleasure to be here. We didn't expect such a huge crowd, but it's really good because Adam and myself, we traveled almost 11 hours from the other side of Atlantic to come here. So really great. And we would like to bring the story how PKO Bank Polski, the largest bank in Central Europe, is fighting fraud with machine learning and network analytics together with SAS. My name is Marcin Nadolny. I'm leading the fraud solutions team in Europe. But I also had a pleasure 10 years ago to work on the project with PKO BP, together with my team of data scientists, developing that strategies with machine learning and network analytics hand in hand with the bank. Together with me, pleasure to have Adam.
Hello, my name is Adam Siok, and I am fraud analytics senior specialist at PKO Bank Polski. I am responsible in building anti-fraud strategies using my machine learning, programming, and analytical skills. I am responsible for building I have over 2 years of experience in PKO Bank Polski, building anti-fraud solutions in the area of loans and credits. And prior to joining the bank, I've been working in DIR as a software designer, where I was responsible for software development and database configuration in the automotive industry. I've earned a Master of Science degree in electrical engineering at Warsaw University of Technology.
Great, so let's start at the beginning with some few words introduction about PKO Bank Polski.
Yes, so let me introduce PKO Bank Polski. We are the largest bank in Central Europe. We have over 12 million retail customers. We employ almost 22,000 employees nationwide. Our customers have over 9 million accounts and almost 11 million cards. We have very strong presence in digital channels with over 8 million active mobile devices, but we also remain open to customers traditionally who wants to go to branch and have over 900 of them.
And PKO, if I probably remember, has over 100 years of history, but they are also a very innovative bank.
Yes, exactly. And our innovation is connected with our great application Eco. Our application not only won the Mobile Trend Awards competition on domestic market last year, but also PKO Bank Polski has won international FinScore competition as the leader of digital banking. And our application has many functions. You can manage your accounts and cards, make investments. You can buy home travel or life insurance. What is more, you can manage official matters in the application, such as submitting social application or signing documents electronically. Or you can make shopping, such as cinema tickets, online TV, highway parkings. And what is nice anti-fraud function of application is that when you have a call from a person who says that he is a bank employee, you can easily in the application, check his identity and safely continue the conversation. It will ensure that you are talking to the right person.
And last but not least, PKO was also innovative in the terms of payments, because 10 years ago they've been pioneering in Poland and Central Europe the mobile payments, the first instant payments transactions done in different ways via mobiles, and we implemented also fraud protection on that payments at that time. So let's have a quick look how it started, why actually PKO BP decided 10 years ago to implement a holistic anti-fraud solution.
Yeah, exactly. Some time ago, we noticed that we have many problems with frauds, which translated into significant financial losses. And the biggest problem was in the area of application, where we noticed more than 6,000 fraud applications for 2 years. But because of our growing and strong presence in electronic channels, we could also see rapidly growing frauds in mobile and digital channels. We also noticed that the fraudsters uses new fraud schemes and new malwares attacked our systems. That's why we needed a solution to fight with this. Okay.
Okay, so how it looked before the implementation?
Yeah, before our journey with enterprise fraud management platform, our fraud detection process was like offline, I can say. Let's say that the customer applied for a loan, the loan was granted, and after some time there would be a manual verification if whether that application was fraudulent or not, quite often after the customer complained or when the loan was not repaid. So the intervention came long after the money had been withdrawn from the bank. That's why we needed a solution that would deal with such business challenges, and also that solution had to deal with the amount of data that we have in PKO, which is hundreds of transactions per second, and a large amount of application that we have every day. And our solution is EFM platform, which stands for Enterprise Fraud Management Platform, that we've built together with SAS. And now the process has changed. When the customer applies for a loan via traditionally in the branch, or he makes payment via online channel, such every transaction is now evaluated online by the EFM platform. So system automatically decides what to do with such operation. And it can be three options. It can be accepted, it can be rejected, or it can be suspended and sent to one of our team of analytics. So when we implemented Enterprise Fraud Management Platform, we also created several team of analytics who has a certain period of time to evaluate such application and transaction.
Okay, great. So let's look what was the scope of the project. So we implemented, as I already mentioned, holistic detection across all of the channels, all of the major fraud typologies, starting from application fraud for both retail and SME customers, extending them by internal fraud aspect, and loan application fraud detection is done in so-called near real time. So within 1 minute we do the assessment with network analytics, with models, with rules, with blacklist matching. Internal fraud is more offline aspect to analyze the things afterwards. Of course, there are some internal fraud aspects also in the online detection. And then in the next steps, we implemented the real-time fraud detection on payments, online payments, internet payments, mobile payments in milliseconds. We also leveraged their mule accounts propensity models, which we'll talk about later. And then also deployed the solution in card fraud detection in real time and branch transactions fraud detection. And one more thing that's important to mention, before the implementation, bank had data in different silos, so it was not easy to combine the data from, for example, card transactions with the data from online payments to understand the customer behavior holistically. Data in some of the data sources have been very poor quality, and that's where you are talking especially about the text data or unstructured data. That was the case when we talk about addresses, for example, of the customers. Bank had not been using any advanced analytics at that time, so no any machine learning, no network analytics, just rules approach. But also, they've been not able quickly to react to changing fraud trends, meaning the rule development process was purely IT-driven process, meaning it takes days or even weeks to develop, test, and deploy, simple up to complex rules. The investigation has been also time-consuming because investigators need to pick up data from different data sources to understand what's happening that exactly on the given case. Of course, there was also a lot of regulatory pressure, and as I already mentioned, the bank had some data in unstructured form. After the implementation of the solution, a bank had a single end-to-end platform covering the whole process from the ingesting the data through data standardization, applying then analytics and up to the outcomes, results. As I already said, they have a holistic now view of the customer, 360 view of the customer. So if there is a transaction that happened milliseconds ago in the card transaction in Moscow, and now we have a transaction, online payments from the IP in Orlando, at that online transaction, we already know what happened milliseconds ago with the card transaction, and we can also, for example, apply the distance rules to see, something suspicious, we can raise this. Just a simple example, but it's much broader. And the bank has now the capability to have the data in the one place, in one repository, which gives them easily ability to analyze the data, to have quickly the insights. After the implementation of the solution, they also are capable now to develop, test, and deploy rules on production in minutes. So even within half an hour, they're able to react to new fraud trends, and that's purely in the hands of the business teams without any involvement of IT. Of course, machine learning and network analytics is here also implemented, and this will be the core of our second part of the presentation. And with the investigation interface, where the alert analysts have all of the information in one place, it's definitely speeding up and improving their decisions. One more thing about analytics. Well, some of you maybe know this slide, but just to highlight to those of you who haven't never seen this. At PKO BP, we implemented so-called hybrid analytics approach. Hybrid in terms of two dimensions. One dimension is dimension of level of detection. So we are looking if there is not something suspicious on the event level, so application level, payment level, but we are also looking on the entity level, customer, account, card, device, address, and on the network level, so network of interconnected entities. So that's one dimension. Second dimension is dimension of techniques that we use. So of course it's about business rules, both simple and complex, that code known fraud behavior, and that came initially from based on the SaaS experience from our customers worldwide. But of course, PKO BP expert implemented their own rules as well. Then of course there's capability to match with in real time with watch lists, anomaly detection, but of course machine learning models to detect complex fraud patterns based on historical data, and network analytics in order to help us to understand organized crime and other suspicious activities, which we'll talk about in the next slides. So Adam, give us, the example of the online banking payments.
Yes, let us follow you through two examples which will cover analytics starting from basic business rules up to network analytics. The first scenario covers online fraud in electronic channel. Let's say this is quite often situation. Let's say that the customer finds a seemingly good bargain, for example, on eBay, and to make payment, he gets a fraudulent link, which the customer clicks it, and the fake PKO BP website appears. But it looks almost like a real one, so the customer just puts credentials there, and now the fraudster can use those credentials to log into the real website. And shortly after doing it, he is trying to add a new trusted payee to the beneficiary list. But to do it, he needs another code and another authorization code from the SMS message that the customer got. And if the customer doesn't sense anything suspicious in that moment, he will just put the code into the fake website. It often happens when the customer doesn't read the details of the SMS message. So he's doing it, and the next step of the fraudster after addition of the new trusted payee is transferring all of the customer's money to the customer's main account. So he's doing me-to-me transactions. And the final step of the fraudster is remittance of all of the customer's money to the new trusted payee account. But that transaction is blocked by the EFM platform because we have a business rule which says that if there is a login from a new IP or a new operation system or new browser, and then addition of a new trusted payee, and at least one me-to-me transaction in less than 30 minutes, and remittance of large amount of money, for example, $1,000 or $5,000, such transaction is blocked. Of course, it can go other way around. For example, firstly me-to-me transaction, then addition of new trusted payee, it will also be blocked. And what is more, if the added account by the fraudster is on our watch list of bad accounts, I would say, it would also be blocked by this way. So our system can block transactions in many ways.
Yeah, so what is used here in that process is not only about the rules, like sequential rules, but also matching with the watch list, with known mule accounts, or with the mule accounts potential list coming from the model, which we'll talk about later. There is also a real-time machine learning model that assesses transaction. Yes. And also we are using here also another watch list related to customer, victim propensity to phishing. So we'll talk about this as well. So, yes. And another example that we want to bring to you is from the application front domain. So what we've seen in the bank data, that's inspired by the real case, right? And let me bring this to you, that story. We have Mr. A and Mr. B who, established company AB. That company is applying for the loan, and they are not paying that loan. They are went with the money. That's a fraud. But then later, what's happening? There's also Mrs. B, who applies for the loan, personal loan. She has the loan granted. She's also not paying the money and is disappearing. Then we have company BC, which is also submitting a SME loan application, and then it's also disappearing and not paying. With the network analytics approach, we could, already here know that the next one could be suspicious. Why? Because Mrs. B, she is on the one side living under the same address as Mr. B. On the other side, she is also employed by the company AB, and that company issued a salary or certificate for the personal loan application, which was here required. So already two connections. With the case which is actually a known fraud, we should already here, decline, or we should at least raise an alert and make the further investigation. The other case is, also similar but a bit more complex. Here, the company BC has other types of connections, like phone number, the same as in the application from company AB, and the same as a customer file from the Mr. A. Yeah? So you see, network analytics, that's a simple example, but that kind of network connections are important in the detection of some types of fraud. Another case, which is not on that picture, but it could be pretty similar, is the collusion between employees and customers. We have seen a case where there was a branch director who was involved in the process of granting SME loan, and then that company also disappeared with the money. But what came out, looking retrospectively on the data, on the network, that actually that lady was living under the same address as one of the co-owners of the company. So she should not be engaged in that process, right? That should raise an alert, definitely. Yeah? Good. So I would like now to go a bit more deeper into the network analytics and then machine learning, starting from network analytics. So this is pretty end-to-end network analytics process here, from the data, through data cleaning, standardizing, entity resolution, network generation, up to defining network statistics and using them in scoring. So in PKO Bank Polski, we used following data sources in that process: credit applications, credit bureau data, and that's why actually in Poland we have a credit bureau that serves all of the banks, and they have information of all of the applications from the market, with even detailed data from the application, including customer personal identifiable information like addresses. Yeah? So that was really good source of information for us. We used also data, of course, from customer file, from employee file, because we want to look on the employee, on the internal fraud aspect, and from watchlist. We also used transactions, but we haven't used transactions, raw transactions in the networks generation. Rather, we looked for the connections of people who transact frequently with each other or who transact significantly with each other. Yeah? So that's what we used. We looked on such fields like first name, surname, address, phone number, email address, documents IDs, citizen ID, company ID, and that, as you can imagine, some of those data had bad quality, or they've been different in different systems, especially when you think about bank systems and about credit bureau systems. There could be some differences. Even when you think about how the addresses are written, could be written properly but differently. And for that we use standardization, data cleansing to bring the data to the level that we can then later match them together. We performed entity resolution, so we looked to identify entities. And what I mean here, just to bring you a similar example, in order to identify the same person who could be differently represented of different systems, there can be some misspellings, some lacking informations. We see here Jan Kowalski with the date of birth known, no address. We have another guy, Jaś Kowalski, so you see her already small differences in the names. The same date of birth, but we have also an address, and we have the third Jan Kowalski only with the address. Yeah? So entity resolution allows us to spot actually if this is the same person or not. And when you look further, actually, right, you see that the first one is the same as the second one because they share the same date of birth. After standardizing the data, we also know this is the same guy. The third one, he is living under the same address as the previous one. That has the same document number, but a different date of birth. Yeah? And we could think, okay, maybe this is a different guy, but because of the other common information, we can identify, okay, there is some mistake with the date of birth, which we may also correct from other systems, and it's rather the same person, the first person. Yeah? And then we have another guy, Stanisław Karwowski, who, well, also has the same, is the same person. We are looking on that based on his first name, surname, and the address. Yeah? That's just a simplified view. There are much more complicated things behind, yeah? And we are also looking to standardize email addresses. We are looking to standardize also phone numbers and so on. Now, what is happening after? So when we did entity resolution generate networks, we decomposed them into communities, and then in the next step we described communities with the network statistics. PKO Bank Polski is using just business statistics. So like we describe networks with such variables like number of frauds in the network, number of customers in the network, some velocity. We look also on some velocity aspects. If in the given network we see that there's a sudden increase of applications, for example, that might be also suspicious. So many measures. I think we defined, well, dozens of measures, and that measures have been later used in scoring, both in rules and in machine learning models. At the beginning of the project, we just used this in the rules because we simply didn't have networks calculated backwards historically across the previous 3 years. But as soon as the system matured, bank was also able to use this in the models. And where the networks are helping us here, in many cases, right? So one case is about hiding identity. So we've seen in the real data the case where there was the same person changing first name, changing surname, but always we've been able to see some other connections. Sometimes the phone number was repeating, sometimes email address, some address. So at the end, we've seen there was a kind of network with the same person, but 8 times with the different names or different details. And when we presented this in the steering committee during the project implementation, they said, oh yeah, we know this case, right? It took us a long time to to spot this manually before. Suspicious communities, of course, organized crime groups. We had such cases where we had multiple, let's say, fake companies issuing salaries of certificate for many people per purpose in order so they go, they take a credit and they withdraw the money. Yeah? So that networks really help us to spot this kind of organized companies. Of course, collusion between employees and customers, I already mentioned this, and well, direct, indirect links to known fraud cases. Yeah? So now, Adam, give us more insights about machine learning models that you implemented.
Exactly. So network analytics, business rules, and watch lists are very powerful, but we can get much more out of them and our other additional data using machine learning. Yes. And so EFM platform takes data from a lot of places, a lot of sources from the bank. Some of data is taken online, and some of data is taken offline. It's processed, aggregated, and transformed into valuable information. So this is the feature engineering that we can use building machine learning models, which can give us a better chance of inferring a risk of fraud. And in case of application fraud, there are three segments. Retail segment, small, medium, and enterprises and corporation segment, and segment of others. Others segment contains auxiliary models, for example, for capital group company or internal fraud model. And in case of retail and SME segments, some of the models are online models, and some of them are offline. In case of online, the situation is as follows. The retail segment is divided into branch and digital channel. The branch has 2 alerting models. Digital has 2 alerting models and 1 rejection model. And corporation has 2 alerting online models. All of these segments uses one mule machine learning offline model, which output is the watch list of accounts that are marked as mule. And what is more, the digital channel also uses 3 phishing machine learning models. They are also offline models. And the output of this model is there are customers who are susceptible to phishing.
So to complement them, so those alert machine learning models that are application fraud models that work in real time, as you mentioned, some of them reject automatically, some of them just write alerts, and they work in real time. The mule accounts model and phishing model, they are used, of course, here also in the context of looking on the customers during customer onboarding. Well, not onboarding, during the process of granting the loan for the current customers. So if the current customer account is on the mule account watch list or on the phishing list of with high propensity to be the victim of phishing, then of course that also taken here into account. But those outcomes of those models is also used in the online payments fraud detection. It's not only in the application fraud, of course. Yes. Yeah? So now let's look on the 3 types of models that you discussed.
Alerting and rejecting models, as I said before, are online models, and we've built them as another class of anti-fraud solutions. And what data do we use to train these models? We use data from customer ABT, which stands for analytical base table. And this is data aggregated at the level of each customer, data from account ABT, network statistics, business rules, data from online application, for example, income or liabilities. And also, as Martin said before, every time the customer applies for a loan, we send a request for data to Credit Information Bureau, and we also use it. As a target, we used not repaid credits, fraud identified by the analysts, and entries on our strongest watch lists. And yes, I wasn't allowed to put exact results of our models, so I put them into ranges. And in case of retail segment, the area under curve statistic on the test set, AUC, ranges from 0.10 to 0.95, and the lift on the first percentile of the test set ranges from 15 to 20. SME model is a little bit worse because we have less data to model it. And the ALC ranges from 0.8 to 0.9 and lift from 5 to 10. I could notice that the most important variables in these models were related to account ABT, but also from network statistics. For example, number of people on watch lists in the social network of the customer. And yes, and we use score from these models as a business rules. In case of alerting models, if the score is high enough, the application is alerted and directed to manual verification by the analyst. And in order to reject the application, not only the high score is needed, but also the entry on one of our strongest watch lists. Because we could, if only high score would be needed, we could deny many applications. That's why we wanted to not to do it.
And what is important to supplement is that model was worked well both for the customers of the bank, where we have more information. Then we have information that customer analytical base table and account analytical base table, but also for the customers who are new to bank, so we don't have these informations, but we have strong information coming from credit bureau, from application itself, from network statistics, but also indicators from our business rules that we developed. Yes. And I remember you told me that, well, the most predictive variables been from the network statistics, right?
Yes.
Place as well, but also sometimes from the credit bureau, right?
Yes, it's often when the new customer comes.
Yeah, exactly, because they don't have that information. Yeah? Good, so let's look now on the mule propensity model. So that models run real time. Yeah. That scores application in real time. Within the minute there is a decision with this model. Now we are looking on the model which is for mule propensity.
Yes, exactly. The mule propensity model is an offline model, and it's recalculated once every 3 days. And its task is to detect the mule accounts and accounts that are used for criminal purposes. And what data do we use? We use data from customer ABT here, account ABT, and customer file. As a target, we've used entries on watch lists which indicated accounts marked as mule. Yes, and the build model is very effective. It has high AUC and lift values. And the most powerful variables in this model were this related to account existence, length of existence, and the characteristic of the account holder.
So demographics, right?
Yes.
Demographics and the history with the bank, yeah?
Exactly. Yeah, and what's more?
So
we also use that model as a business rule. So when the customer applies for a loan, we check his account, score of that account, and if it's high enough, it's alerted. And after implementation of that model, we've reduced a lot of loss of money, which is related to fake identities, which resulted into the higher value detection rate statistics.
But that model, as we mentioned, I mean, so that generates a list.
Yeah.
You have a score on the list of accounts. Bank makes a cutoff, right? And then that list above the cutoff is provided as a watch list for application fraud process for the customers of the bank, but also it's a watch list for the online payments. So if the transaction for the new beneficiary would go to such account on that list, that could be automatically action taken, either a transaction declined or hold on and alert generated. Yeah? Exactly. So, and the last one is, I think, the most interesting. That's one of the new developments of the bank. Yeah?
Yes, exactly. The mule customer susceptibility to phishing models are also offline models are also recalculated once every 3 days.
So this is kind of victim propensity model for phishing, yeah?
Yes, exactly. So not only education is needed, but we can build models to secure our customers against fraudsters and themselves, to be honest. And we've built this model because of a large number of customer complaints related to money scams. And as a data, as you can see, we used customer ABT, network statistics, business rules, online application, credit information bureau, and customer file. And we've built 3 models as a part of a phishing. They differ in the target. And the target was created based on customer text in the customer complaints, and the complaints were categorized based on appropriate phrase in the text. And the first model concerned frauds related to investments into cryptocurrencies or other financial instruments guaranteeing high profit. The second model concerned frauds resulting from impersonating a bank employee or other financial public institution trust. Yeah. And the third model concerned frauds related to purchases online. All of this model has a good results, but the best one is related to the one related to investments. And I could see that the most important variables in that model are this related to transaction activity of the customer. Yeah. And after implementation of these models, we highly reduced complaints related to our customer complaints related to money scams, because these models indicate customers who are susceptible to phishing.
So of course you should educate customers for being aware that what's happening, that they should be cautious about reacting to the scams. But on the other side, on the other side, you can also try to protect. You can identify the most vulnerable customers and then take a special approach to them, right? Yeah. Alert on their transactions, call them with the specific script to trying to convince them that they should not send the money to a suspicious account. Yeah?
Yes, exactly. Some of the customers.
Which variables, which types of data have been the more predictable for that case?
Transaction activity of the customer. So, for example, when the customer is doing a lot of transactions via internet, he can be more susceptible.
Good. So, with that, we are coming to the conclusions. So, you've seen at the beginning how PKO Bank Polski was working before implementation of the holistic approach, how they've been able to react to the fraud trends, what weaknesses they have. Now, after the implementation, as we mentioned at the beginning, they are the end-to-end platform. So all of the data from different sources, card transactions, online payments, branch transactions, in employee systems, applications, even external data like from credit bureau data or cybersecurity data from other systems in the bank, they are coming in the system via batch or via real-time APIs, and giving us a possibility to have a holistic view of the customer to react properly, understanding all of the customer behavior. Yeah? There are, of course, also profiles that are updated after every single transaction, after every single application. And I already mentioned before that with the rule development capability now, it's fully in the hands of business users. They are able now to quickly react to changing fraud trends. They don't need to wait for IT for days or weeks to deploy something complex. And that's a huge advantage. Adam, what are the advantages on the other side?
I think directly for the bank, the biggest and the most tangible benefit of the project is the reduction of fraud-related losses, because we can identify frauds earlier, before money leaves the bank. So for the bank, this is the positive financial outcome of the project. What is more, fine-tuning business rules and our anti-fraud solutions with our machine learning models reduced our false alarms. And to sum up, EFM platform speeds up investigations thanks to social network tools or alert management tools that our analysts can use.
And as I remember, because I was, as I mentioned, a part of the project implementation at the beginning, participating in many steering committees, I remember also that, well, we've been told, we don't have this on the slide, but I remember that, that the bank told us, well, just after application fraud implementation, half a year after going live, they notified the full return on investment, yeah? Because they've started from nothing to the point where they implemented the approach with machine learning network analytics. Yeah? So really, really huge benefit. They also have been able then to catch quickly huge frauds, online payments fraud in the SME area. Yeah? So that was really great. That's it, what we prepared for today. It will be a pleasure to have maybe some questions, but also you can contact us afterwards. You can meet us also somewhere here in the floor. You can search us on LinkedIn and connect to us. It was a pleasure. Are there any questions? Yeah?
Idziemy na górę? Bo...
Że tutaj. Możemy tu wejść.
Hi, can you hear me? Yeah. Can you hear me? Yeah, thank you.
Yeah.
So this is very impressive, very exciting. You talk about the data being, previously it was all in silos, and you brought it all together to one single platform for enterprise fraud. But what about marketing, customer loyalty stuff? Do they still have the silos, or did you build an enterprise platform for all use cases, or your platform you build is just fraud?
Okay, so that was covering fraud area. SaaS is present also in other areas in the bank, like in risk, for example. That's not fully integrated yet. That's a huge bank. As Adam mentioned, 20,000 employees.
Right.
A lot of internal politics as well. There are discussions to integrate these closer together, but it's, you know, it's not a short process. Yeah.
Right. Thank you. Thank you.
Any other questions?
Thank you, Adam and Marcin. That was a delightful presentation. Thank you. Well, regarding your customer susceptibility to phishing target, the dependent variable, right? How are you defining it? Like you said that you're relying on the complaints, right? Are you doing some text mining, or like how are you differentiating investments versus the other types that you listed?
Exactly. As you mentioned, we are doing text mining, and we are looking for exact words in the customer complaint. For example, for the model related to investments, we were looking, for example, for words like Bitcoin, investment, or something like that. In case of impersonating, that was a bank employee, and so on. And in online purchases, something like BLIK, which is
mobile payment standard in Poland.
In Poland, yeah, and we are doing like that.
One more question, yeah.
Just revisiting the same question of the gentleman who asked the first question. So for those fraudulent activities that you've identified that are more highly suspicious or already deemed fraud, were you guys able to provide data to your marketing or even your application to block them before they come back, to provide some to block some reoccurrence of fraud?
Okay, so as far as I know, but you can supplement me. I mean, I was also closer to the deployment of some of the strategies. There have been, in case of marketing campaigns for the current bank customers, the marketing list been generated to leverage, of course, the cross-sell, upsell scores, so from a marketing perspective, but also the fraud scores been also used to eliminate some people from the lists. Also, that was leveraging also credit risk scores. So they have a kind of holistic approach to propose the new products or upsell, cross-sell to the current customers. Well, not doing this when it's not reasonable to do. Yeah. Good. Thank you very much.
Thank you very much.
If there are any more questions, feel free to chat with us.